Hey everybody, it's Mr. Gubino here. We're going to be doing the graphical medley for AP Review. This is my fourth video that I'm doing tonight, but I'm sorry, my first video that I'm doing. You'll notice that they're all recorded at the same time, but only one person out there knows what I'm talking about with my wardrobe changes for each video. You know who you are. And you know the reason why you know that. Okay, so we're going to get into the graphic medley. Sorry. It is getting late, so I'm hoping to keep this under a good 20 minutes. So I know a couple of the ones did tonight. I mean, this is my first one I've done in the past. They have become longer. All right, here's that Luna wipe. No, actually, I'm going to do swipe. So let's see what this does. Oh, hi. Okay, so here we go. So the graph of f is a continuous function on the interval from -5 to 4, as shown above. The graph of f consists of 5 line segments and 1 semicircle. Let c of x be the absolute value of f of x. For 0 to 4, c of x models the number of people in hundreds in the warehouse x hours after 8 a.m. All right, so kind of looking at this in a sense, a way that we're looking at this, the absolute value. What would happen is this point, anything that is below, is now going to be essentially above, right? Because it's the absolute value. And when you take the absolute value, you're going to get everything above. So up here, this one would be up here. So you wouldn't see this part or this part or this part there. So what it would look like is your graph would look like that if it was the absolute value. Absolute value of f of x would look like that. But because we're only looking at a certain part of the time, we're only looking for this part. 0 to 4 hours. Here's my 0 hours. Here's my 4 hours. They want to know, in the first case, c of 1, which is going to be the absolute value of f of 1. So in this case, c of 1 is going to be 1. So at t equals 1 hour after 8 a.m. Oops, 8 a.m. Remember, scribble out. You're gonna use your pencil on the test, so you can erase, but just watch how you rip your paper, depending on what kind of eraser you have as well. Some of those pencils have the not so good erasers, so just be aware. You could say at 9 a.m. So this part right there, 1 hour after 8 a.m. is 9 a.m. There are 100 people in the warehouse. Okay? Or you could say 100, write out the word 100. Okay? So that's part one of the other one. So the next one is they're asking for c prime of 3.5. All right, so c prime of 3.5, well, that's going to be f prime of 3.5, and that is going to be the slope, the slope at 3.5. So it's a rate at 3.5 hours after. All right, so at 3.5 right here is about right there. I need the slope of that line. Well, you know, c is equal to this, so this is equal to f prime of 3.5. What's the slope at 3.5? Well, that's a linear function because it said it's made up of lines. So what's the slope of that line? So if I go from 3.2 to 4.0, 3.2 to 4.0, change in y over change in x would be -2 over 1. So the answer to this part D, part 1, part D, would be the amount of people in the warehouse is, because this is negative, decreasing at 200 people per hour. Now, oh, sheesh. Again, Mr. Goubinot. All right, so C prime of 3.5 is the same as F prime of 3.5. So I need the slope at 3.5 from my graph. And at 3.5, I need the slope of that line. That's a linear function, so which is -2. So the amount of people, this is your answer that you want to write. The amount of people in the warehouse is decreasing at 200 people per hour. You do not need to write decreasing at -200 people per hour. Because you're using the word decreasing, you're assuming that net number is negative. Okay? Does that make sense? I'm hoping. Make sure you use correct increments or units. There's your units, people per hour, because we're finding the change in time. Okay. Next part is going to be, this was part A, and we're going to go to part B down here. All right, so B, C, and D all deal with the same graph, just another version of that problem. So what I'm going to do is I've just rearranged it a little bit, so I'm going to put K of 1 and K prime of 1, and we're going to show you what's going on. So I'm going to copy down this problem again. I'm going to go blue. So K of x is from 0 to x of f of t dt. All right, reminder, fundamental theorem of calculus. Second, if you see the x on the top, you see a dummy variable for t, for that x. All right, so part A, or part B, B is down here. They want k of 1, which means that you want 0 to 1 of f of t dt. All right, so you want f of 1 dt. So you want the function value, because this is area under a curve. And so what you need is you need the area of 1. So this is what area you are trying to find. Well, this is a semicircle because it told us that. This is a radius of 1, and it's 1/4 of it. So this is going to be negative pi over 4. Why is it negative again? Why is it negative? Because I started at 0. I started at 0 and I'm going this way. So anything below is negative, anything above is a positive area. If I start at 0 and go this way, then anything below becomes positive, anything above becomes negative. Keep that in mind, because I think there's a couple where it's going to be. All right, k prime of 1. All right, so I'm going to use k of x is equal to the integral from f x of f of t dt. So I'm just rewriting it. K prime of 1, I need k prime of x. Well, how do I get k prime of x? That's right, you take the derivative in terms of time. So the derivative in terms of time. Let's make sure it's in terms of time. Yeah. Okay, so this would be f of x. Oh, well, k prime of x is f of x. And if I want to know k prime of 1, k prime of 1 is going to be f of 1 And the function value at 1 is this point right down here of -1. Good writing, good support. Put a little box around everything. Good to go. All right, part C. Part C finds the average rate of change, oh boy, of k of x on -5 to 0. Average rate of change of k of x. All right, so the average rate of change of k of x, which is k prime, yep, k prime, is going to be f of, or in this case, sorry, yeah, no, k of, sorry, k of b minus k of a over b minus a, and they want to know the average value between -5 and 0. So I need k of b value would be 0 minus k value of -5 over 0 minus a -5. All right, so this is going to be, what is k of 0? Well, k of 0, let's go back over here. K of 0 is if I go from 0 to 0 of f of t dt, because, reminder, this is k of x, right? And if I plug in 0, I get a width of 0. So this value right here is going to be 0. K of -5, k of -5 is going to be from 0 to -5 of f of t dt. If you want to look at it another way, go -5 to 0, you're going to flip it, basically. And if you flip it, if you flip the integral, it's the negative area underneath. So what is the area between -5 and 0? So here's -5. Here is 0. All right, so this is 1. That's an area of 1. This is a 1 by 2 triangle. There's your 1. This is a height of 2, area width of 2. So this is 2, and this is 2. So if I'm going left to right, I go 1 plus -2 plus 2. I would go -1 plus -2 plus 2, which is -1. So 0 minus a -1 over 5, which is going to be 1 over 5. What are the correct units? Are they asking for units? Find the average rate of change. Oh, they do not. But average rate of change is, if they ask, people per time. Hour, people per time. So it changes at 1/5. 1/5 people per time. Okay. Okay. D, verify k of x satisfies the mean value theorem on the interval from -5. State how many times k prime of c, the value guaranteed by the mean value theorem, occurs on the interval from -5 to 0. All right, so what we need to look at is we need to go back to the graph. So part D is we're looking at the mean value theorem. And what we're doing is we're looking to see when, k prime of x is equal to f of x. And in this case, we found it by 1/5. So what we're doing is how many times will that value be 1/5? So what we're going to do is we're going to look at this graph. We're going to take our graph and we're going to think about where f prime or f of x equals 1/2. And we have 1, 2, and 3 times. We don't include this one and this one. Why? Because it's not in the interval from -5 to 0. So the mean value theorem guarantees, that's too old for you guys probably, guarantees that k prime of x equal to 1/5 3 times. Okay. State how many times k prime of x is equal to 1/5. 3 times. All right, last portion here. And that last portion deals with, oh look, the same graph, but this case, it's a different function. So if I'm dealing with a different function,